going to start this lesson by considering this. Tom gets paid hourly to do landscape work. Because he is such a good employee, Tom is planning to ask his boss for a bonus. Tom's initial pay for a month is shown. He is trying to decide whether he should ask for an extra $5 per day or a 10% increase in his daily wages. So instead of going through and adding $5 to all his data or adding a 10% raise to all his wages, what we can do is do a transformation of the data looking at either the 5-number summary or the mean and the standard deviation. A $5 raise is considered to be a linear transformation. It's done when you are adding or subtracting, for that matter, $5 to all the data set. So Tom's daily pay after the $5 bonus can be found by using y equals 5 plus x, where x represents his original daily pay and y represents his pay after the bonus. That looks very much like slope-intercept form, which makes a straight line, which is why this is called a linear transformation. So below we can see a dot plot. Yes, I know it uses x's, but it's still a dot plot on a number line that shows his wages before the $5 and his wages after the $5 is added. Notice that the shape of the distributions are exactly the same. Now it does shift all of his wages $5 to the right on the number line, but again, the shapes are exactly the same. Notice the median before his bonus is 50, and the median after his bonus is 55. So he's just simply, we could find the new median by adding the $5 to the old median. That is true for the mode as well. The mode for before the $5 was 52, after the $5 is 57. And it is also true for the mean. His mean wage was 48.6, that would represent $48.60. If we add 5 to that, we would get the new mean of $53.60, 53.6. But notice that the ranges and the standard deviations are exactly the same. The range of the old data set is 18, and the range of the new data set is also 18. Standard deviation is 4.9. When you add $5 to everybody, its standard deviation is still 4.9. Hopefully both of those make sense, because the standard deviation, remember, is computed by finding the difference between each data point and the mean. And if all the data points and the mean are $5 higher, then the difference between each data point and the mean is going to remain unchanged. So that's why the standard deviation is the same. So if we are transforming a data set using addition or subtraction, the mean, median, and mode of the new data set can be found by just adding whatever that value is, that's what the K stands for, to the mean, median, mode of the original data set, and the range and the standard deviation will not change. So example number 1 is to find the mean, median, mode, range, and standard deviation of the data set obtained after adding 7 to each value. So instead of going through and adding 7 to each value, going through and say, well, I'm going to put in 20, and then 5 plus 7 is 12, and 8 plus 7 is 15. So instead of doing that, we're going to just find the mean, median, mode, range, and standard deviation of this data set, and then we will add the 7 to the mean, median, mode, but the range that we get for this data set will be the same for the new data set, even after adding 7 to each of the individual values. So let's go to a box plot generator to figure that out. I think that'd be the quickest way to use technology. So we will go to a box plot generator, and we will type in that data set. Okay, so I've typed in the data already, so I will submit that data. And there's our box plot generator, and we're looking at to find the mean, median, mode, range, and standard deviation. So this one automatically shows you the mean. So if you look over to the left here, I can blow it up, you can see that the median is 8. So the median of the new data set is going to be 8 plus 7, which is 15. To find the mean of this data set, I just need to click on the mean button. So you can see the mean is 9, so when I add 7 to that 9, that means the new mean is going to be 16. To compute the mode, I can just click on the mode button. And you can see the mode is automatically computed to be 8. And then we need to find the standard deviation and the range. Now remember that we're going to add 7 to the mode, which means the new mode is going to be 15, but the range and the standard deviation are going to be unchanged. So let's do the range first. So this is the range of the old data set. So even though you add 7 to all of the data points, the range will remain unchanged. So the range is going to be 10. And then to do the standard deviation, we'll hit the standard deviation hyperlink. And the standard deviation of the old data set is approximately 3.34. So that will remain unchanged for our standard deviation of our new data set. So to answer all the questions on this, the new mean, remember the old mean before adding was 9, but the new mean after we add 7 to the data set is going to be 16. The old median was 8, but when we do the new median, that's going to be 8 plus 7, which is 15. The old mode was also 8, so the new mode will be 15. But the standard deviation and the range will remain unchanged. So the range of the old one was 10, the range of the new one is still 10, and the standard deviation of the old data set was 3.34, and that will be the range of the new data set. So the answer is all the new data, and that's going to be that right there. We can also see the effect that a daily increase of 10% will have on the data set. So going back to Tom's earnings, we still have Tom's earnings before the extra 10% on the left side. But look what happens to Tom's earnings when we add 10% on the right side. The mean, median, mode will all increase by 10%. So his median was 50. If you get a 10% raise of 50, that means you're going to get 1.1 times the original amount. So 1.1 times 50 is 55. So he would get $55 with a 10% raise. The mode is 52. If you do 1.1 times 52, that would get 57.2. And the same for the mean. The mean also increases by a factor of 1.1. With multiplication or division for that matter, if you do range and standard deviation, they will also increase by a factor of 1.1. So the old range is 18, but the new range is going to be 18 times 1.1, which is 19.8. Standard deviation was approximately 4.9, and if you take 4.9 times 1.1, you get approximately 5.4. So if you are multiplying or dividing, then the mean, median, mode, range, and standard deviation of the new data set can be found by multiplying each of the original statistics by whatever that factor is. So different than adding or subtracting. With adding or subtracting, the mean, median, mode change, but the standard deviation and the range remain the same. But if you're multiplying or dividing, all 5 of the measures, mean, median, mode, range, and standard deviation, will all be multiplied by whatever the factor is. So example number 2 is to find the mean, median, mode, range, and standard deviation of the data set obtained after multiplying each value by 3. So we've got our data set there. We're going to multiply all those data points by 3, and that would give us a new mean, median, mode, range, and standard deviation. Or we can just type in the original data set and then take whatever mean, median, mode, range, and standard deviation they give us times 3. So let's do it that way. So I'll go back to my box and whisker plot and type in the data set that you see on your screen right now. Okay, so I've typed that in already, so now I will submit the data. It takes me to the box plot, and we can see that the median, again, on the left side, we have a median of about 16.5. So the new median will be multiplying that 16.5 times 3, and that will give us 49.5 for the new median. Again, with the box plot generator, we do need to hit each of the hyperlinks to find the other measures. So let's go to the mean. So here's the mean. The mean is 16. So if I were to take that mean times 3, that would give me 48. I will also click on the mode. So there is the mode. The mode is 12. So 12 times 3 would be 36. And then to do the range, I'll click on the range. The range is also 12, so 12 times 3 would be 36. And then finally, I'll do the standard deviation, so I'll click on standard deviation. And you can see the standard deviation is approximately 3.7 if I rounded it to the nearest tenth. So 3.7 times 3 would be about 11.1. So to answer all of the questions, find the mean, median, mode, range, and standard deviation of the data set after multiplying each value by 3. Remember, the old mean was 16, but we're going to take that times 3 to get the new mean, and 16 times 3 would be 48. The old median was 49.5. If you can read my handwriting there. Excuse me, that the old median was 16.5. I'm getting ahead of myself. But the new median is 16.5 times 3, which is the 49.5. The old mode and the range for that matter, they were both coincidentally both 12s. So if we take those 12s times 3, we'd get a new mode of 36, and range will also be taken times 3. Again, that is different than if we're adding or subtracting. We don't change the range if we're adding or subtracting. But since we're multiplying, we'll take that times 3 to get 36. And then finally, the standard deviation was approximately 3.7 of the original data set. But when we take that times 3, we're going to get about 11.1. So back to the original question is, which raise should Tom ask for? So I've already written out in a chart here what his mean, median, mode, range, and standard deviation was from the dot plots with the $5 raise and with the 10% raise. And notice that the median and the mode are identical no matter which type of raise he wants. The mean is slightly higher, about a dime higher per day or per pay period, and the range and standard deviation are actually lower. A low range and standard deviation actually shows consistency. That means he kind of knows what he's going to be paid basically per day, whereas with the 10% raise, the range and standard deviation is much higher, which means he has a much wider variety of pay, and he also has a lower mean. So if this were me, I would say Tom needs to ask for the $5 raise because he is getting a little bit more on the mean, and with the low range and standard deviation, it is much more consistent, and he'll know what he's being paid from day to day. So I would ask for the $5 raise.